Hello everyone. In this, we will understand Gauss Elimination Method. How do we use this method to solve simultaneous linear equations? Let us understand this method through one example. Solve the system of linear equations using the above. So the equations given are x plus 2y plus z is equal to 3. And then second equation is 2x plus 3y plus 3z equal to 10. Third equation, 3x minus y plus 2z equal to 13. These equations in matrix notation can be written as coefficients. We will be writing coefficient of x in the first equation is 1, second equation is 2, third equation is 3. Similarly for y, first equation it is 2, second equation it is 3, last equation it is minus 1, then 1, 3, 2. This is a matrix multiplied by x, y, z, and that is equated to the matrix 3, 10, 13. We call this matrix as A, this matrix as X, which is equal to this matrix as B. Now, in order to apply this Gaussian elimination method or Gauss elimination method, we will be forming the augmented matrix. The augmented matrix of the above system is, we will be writing it in the form of A is to B in matrix form, which is 1, 2, 1, and then we'll put a colon, then we'll write that B matrix element, which is 3, then 2, 3, 3, put a colon, write down the next one, then 3, minus 1, 2, put a colon and write down the next element. Now, what we will be doing is we will apply some row operations to make this as what do you call? We will convert this particular matrix. I mean, this matrix A into a upper triangular matrix. Means these elements that is below the principal diagonal, will be converting it into zeros by doing some elementary row operations. What is that? So I want to make this 2 to 0. So what should I do? I am now creating a new row 2, and that will be something times new row 1 will be our benchmark row, and then we will be adding the row 2. I'm sorry, not new row 1. It is actually row 1 simply. Row 1 plus row 2. Now, what is that to get multiplied? We will see this element, it is 2, and we will just take opposite of that, means it becomes minus 2. By doing that, what will happen is minus 2 into 1, it is minus 2, plus 2, you get this one as 0. Same way, new row 3 will become now minus 3 times row 1 plus row 3. Means why I am using minus 3, because here it is 3. I am taking opposite sign of that. That's why it is minus 3. Now, based on this, what will be our new augmented matrix? First row, there is no change. 1, 2, 1, colon, 3. Next one. Second row will get changed, which is minus 2 times row 1. So it is minus 2 times 1 plus 2. It becomes 0. Then minus 2 into 2, it is minus 4. Minus 4 plus 3 is minus 1. Then minus 2 into 1, it is minus 2. 3 minus 2 is 1. And then minus 2 into 3, which is minus 6. Minus 6 plus 10 becomes 4. Now, third row, it is minus 3 times row 1. Here it is minus 3 times 1 plus 3, it becomes 0. And then minus 3 times 2, which is minus 6. Minus 6 minus 1 becomes minus 7. Minus 3 times 1, which is minus 3. Minus 3 plus 2 is minus 1. And then put a colon. Minus 3 times 3, which is minus 9. Minus 9 plus 13, it becomes 4. Now, only one element we are supposed to convert, which is this negative 7. So for that, what we will be doing, we want to make this minus 7 to 0. Accordingly, we'll be choosing. So what can be done? If I choose, I'm going to change the third row. New row 3 will be something times. I can now consider this row 2 itself. Row 2 plus row 3. Now I want this to be 0. So what should I do? Here there is a minus 1. If I multiply this by minus 7, it becomes positive 7, then I can add. In the sense, I'll put minus 7. Why? Because minus 7 into minus 1 becomes positive 7. Plus minus 7, it becomes 0. So same logic will be applying to all the elements of that row. So that means first row and second row, there is no change. 1, 2, 1, colon 3, and then 0, 0, minus 1, 1, colon 4. Now, minus 7 into row 2, minus 7 into 0 is 0 only. 0 plus 0 is 0. Then, minus 7 into minus 1, it becomes positive 7. Positive 7 minus 7 is 0. And then minus 7 into 1, it is minus 7. Minus 7 minus 1, it becomes minus 8. And then minus 7 into 4, which is minus 28. Minus 28 plus 4, it becomes minus 24. So we converted the original matrix, whatever A matrix was there, into a upper triangular matrix. Now we know these are coefficient of x. First column is coefficient of x, second column is coefficient of y, third column is coefficient of z. So I can now write this in the form of equations as 1 times x plus 2 times y plus 1 should be equal to 3. This is our first equation. Then there is no x because it is 0 in the second row. So minus 1 times y, then plus 1 times z. This is also 1 times z. 1 times z is equal to 4. That is our second equation. Then third, it is minus 8 times z is equal to minus 24. That gives us this thing. So from third equation, we can say z is minus 24 by minus 8, which we will get 3. So since we got z value, we can now go back to second equation. It says minus y plus 3 equal to 4, which means minus y is 4 minus 3, which is 1, which means y is minus 1. So we got y value, we got z value. Now let us go back to first equation, which is x plus 2 times minus 1 plus 1 times z, that is 3, equal to 3. So both sides we can cancel 3, which means x minus 2 equal to 0 it becomes, which means x is 2. So we found the values of x, y, and z. This based on your Gauss elimination method. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.